Today is Francois Swanepoel from fusionBIM-Scirrus. In this video we will look at the various stages of a project's development, from design to documentation, shop drawings and data, to the manufacture of, in this particular case, of lightweight precast concrete walls and slabs, and how we document that for manufacturing and then for construction on site with a seamless process. Afterwards, we will also be looking at the Scan2BIM process in order to demonstrate how we utilize 3D scanning on construction sites during construction phases to verify and check and inspect the construction work and verify that against design to pick up discrepancies and variations. So firstly, we look at this residential project. In this project, we did a renovation whereby the first floor was added and the construction used was precast lightweight concrete panels for both the walls and the slabs, and how we documented that. So what you see here is the BIM-X Hyper model, and on the left hand side you can see the index where all the drawings are kept, and then the 3D model views separately at the top. You can navigate the model in this BIM-X app. This works on mobile devices, desktop, and in your browser without installation. And this allows you to navigate the project, but also to, on a technical level, to interrogate the model. So I'm selecting this wall and pull up the information of this element. And this is metadata that's embedded in the model elements, which is extracted in these labels and into drawings and schedules that will show along the way. As you can see, ID codes, different lengths, heights, widths, angles, specification notes, keynotes, quantities, volumes, areas, surface areas, areas of openings within this wall, all are embedded and extracted from this 3D model. So we utilize then this to document the project for both design, council approval, also then the manufacturing and procurement, and then at the end of the day for construction, so the contractor knows exactly what he needs to do when at what level. So opening the first floor, in this case focusing on the precast systems. Here you can just see the extent of this particular precast walls and slabs. On this following drawing, you can see how we prepared and designed, along with the engineer, the various precast slabs sections and their supporting structure. Looking at the various outputs, apart from just normal architectural drawings like the elevations and sections, these are pretty normal documentation that goes out for approval and for construction. But note that these labels, these tag labels, pull out information about those elements according to the code into the labels automatically. In the same way, we produce then the construction drawings, calling out the unique ID codes of these different panels onto drawings for the contractor to know which panel gets installed, and the various slabs with their keynote codes. This is just a 3D representation of those elements in the model and the project. And then we can pull out all this information about these panels. As you can see, the volume of these panels, the thicknesses, the widths, the material, surface areas, the quantities of window openings, door openings, and the volume of the openings, as well as then the sum totals of the areas, surface areas. These are then your concrete slabs and concrete roof that was used in this particular design. All this information then helps the contractor to cost and procure and install, as well as then the factory that pre-manufactures these panels. We'll be looking at the next project, and this is to demonstrate the Scan2BIM process. This was a project, mixed-use project, whereby the first two levels are retail. The third level here is office space, and the top level is residential in this particular building. So this building was scanned and modeled for as-built condition, and as you can see in this view, where we cut the model open, that the complete building with brickwork, plasterwork, railings, roof structures, ceilings, shop fronts, everything is modeled in detail according to a 3D scan with LiDAR scanning equipment. And I'll show you where this end result comes from. But before we do that, this is a preview of the point cloud scan, just a particular view from this, and this is the complete visual of the complete scan of this particular building and how it ended up with the completed model from which the architect then did design. So to understand this point cloud scanning, here we have a virtual tour, a 3D representation of this scan, as well as a photographic tour that I'll take you through. So as you can see, this is a full 3D of the complete site that was scanned of this property. And if you could go into the tour itself, you'll see that this is full, high definition photographic view of this particular project and the site. So this way you can do a full inspection of the site, the scanning be done at different stages of construction. In this case, it was an as-built condition. You can use a measure tool and pinpoint the point of measurement and get dimensions of various elements and points in the building. These dimensions have a tolerance of accuracy, which is sufficient for this kind of measurement and just basic checking. This tour in the web browser is the first output from that scan. The next output from that scan is the actual point cloud. As I'm going closer to the point cloud, you'll see that it looks like a photograph, but it turned into these millions and millions of points, which determines the level of accuracy that we can measure with and within the point cloud, because this point cloud file that is extracted from the same scan, one scan, two outputs, this point cloud file becomes the digital survey. No need for manual surveying of these building elements because we are scanning it. So from this then is produced a 3D model. Just loading the model within the scan so that you can see them translated and superimposed in 3D onto one another. And if we switch then the point cloud off, you end up with a complete model of the building, accurate to up to 6 millimeters, sometimes closer. This is then used to produce the drawings, as I mentioned. Just load the point cloud back into this view on the floor plan. Now you can see how the model elements are modeled inside of the point cloud as reference. And this is how we then utilize the point cloud along with the design model during construction to verify that the construction work is aligned with the initial design. The point cloud scan will then represent the construction work after the design, and obviously we're superimposing it on the initial design if it's a construction progress scan that we have done. So that way we can verify that all construction work is accurate, and that is then utilized as a check before joinery work and also precast material and elements is installed on site, so that we know exactly before those materials and installations leave the factory that they will be matching the conditions of site and removing any delays that you might have of elements not fitting correctly. Further in construction, we also use the scanning to be the platform to communicate for inspections by various professionals in the team. These information tags can then be embedded by the various parties, whether it's the plumber, the engineer, the architect, to annotate issues that needs to be checked or actioned, and notifications to the different signed in project members will then receive their various notifications. And like in this example, the initial instruction was to repair the trap on this zinc, and the plumbing contractor came back with a photograph of the repair to report back via this platform and interface, as one record has been kept of everything, all the communication on the project. You can then move through these labels and tags. by means of the side panel, and then inspect all the messages and feedback and notes that has been populated. In this case, even in the 3D view, you can see the room tags and all the labels of communication that has been embedded even into the roof space. That's related to this geyser installation for clear communication on site and to design teams.